Hi everyone. This is the clip I promised you that follows on from the video explanation of trees, which was made in response to a failed recording on Friday. So it'll probably be the first of introduction to the use of Eclipse that you've seen. And next week I'll prompt you to install Eclipse on your laptops and machines. You will find a short video clip on Pharos showing you how to download and implement the system on your machine. It should be quite quick and quite easy, and I might decide to update the instructions. I made the Eclipse video about 5 months ago and things change very, very rapidly. Okay, so what I'm showing you is a Java implementation of the pre-order traversal algorithm. And I start off by defining the class node that I explained in my last presentation. And it contains an integer data variable called data. It has two variables of type node, left and right. And you'll notice straight away that this is a recursive definition of node in the sense that I'm defining the class in terms of the variables of type node. But there's no harm in that. This is a perfectly good recursive definition of this data structure. I also spoke about a constructor called known. A constructor has the same name as the class in which it appears. And the point of this is that it's executed immediately whenever an object is created using this class. So for example, if I wrote CK is of type node and it's the name of a new node instance which has the parameter 44 placed in it, then 44 will actually be assigned to the variable data. And the algorithm I'm giving you, the operation of pre-ordering is specified by also including an object of type root, an object of type node, and the first thing that this operation pre-order does is to check whether the root is null. If it is, it returns. It stops execution and returns a void value. Otherwise, the first thing it's going to do is to print out the data contained in the root using system.out.print. And then I go on to pre-order the left sub-branch of root. In other words, I'm going to explore the left sub-branch of root, and I access that by writing the name of the node root dot left. And when that finishes, I am going to explore the right hand subtree using preorder. So I'm just, as I explained in the presentation, I'm going to conduct the traversal recursively by means of this specification. So in this part of the program, I'm creating in several steps the tree itself. So for example, my root is results from the creation of an instance of the node class, and I'm parameterizing it with value 40. So I've got a root that contains the integer 40, and then I'm assigning to the left variable another node which contains value 20, and on the right the right variable is going to be assigned a node object, which is being parameterized to hold 50. Then the left branch of root's left branch is going to become a new node object, which is being parameterized to 10, and so on and so on and so on. What I'd like you to do is to actually construct a diagram showing me the tree. And I've run the program already, and the result of in order traversing it is 10, 20, 30, 40, 55, 50, 60. So can you check the correctness of that? Let me run it again. All right. It's not going to be a difference, but it's just to show you it in action. And it's showing you how to run a program once you have it within the Eclipse development environment. Okay, so there's plenty of new things to think about here. And I remind you that the first part of Friday's presentation gave you an overview of what I'm going to do in the next couple of weeks. And that's still valid, and I'll put a copy of that document in Pharos, which you'll easily be able to find. And in addition, I will give you the document I wrote on objects, which is important. It's a very important background to understanding what I'm doing here and what I was actually doing in the presentation on trees. So have a look at that. Make sure you do. Have a read of it. And if you have any comments, let me have them back. Okay, and I'll see you next Friday. So take care.